Okay, ladies and gentlemen, the next part that we're going to go into, we have just two parts left of Unit 6, which is quadratic functions and formulas. This is the second to last part, and we are talking here about the intercept form of a quadratic function. And when you think about intercepts, you should hopefully in your mind go back to Unit 3 when we talked about graphing. We talked about the slope-intercept form, and intercept meant where we crossed the y-axis, where it intercepts the y-axis. Well, basically, it's kind of the same idea. It is about intercepting an axis, just like we did. However, this time we're talking about quadratics or parabolas, right? And so the parabolas, they are shaped like a U, and so when you have a parabola shaped like a U, you're actually going to have two times that it intercepts, and instead of intercepting the y-axis this time, it's going to intercept the x-axis. Okay, so it's going to intercept the x-axis twice, and so you should have two intercepts. Okay, just kind of makes sense. Now, the equation that I have written here, y equals a times the quantity of x minus p times the quantity x minus q, is the form of the intercepts. Okay, and if you get it in this form, it makes it really simple. Now, if you're looking at that, hopefully you kind of see like that almost looks like if we took a quadratic function, you know, our regular functions we've been working on in Unit 5, and you factored it, you pulled out a greatest common factor, and then you just factored it down into two sets of binomials. Okay, that's what that looks like, right? It looks like here you have like your GCF, and then it looks like one binomial times another binomial, which is what we were doing when factoring, right? So that's kind of what this is here, and it's kind of a quick way to go ahead and graph your parabolas. Okay, now here's the important parts of what you need to know and what you need to use. Okay, first of all, the A is just like the A that we've always had in our quadratics, and the A is what tells us which way our parabola is going to go. And so if your A is positive, your parabola is going to go up, and if your A is negative, it's going to open up to the down. Okay, open down. All right, and then your P and your Q are going to be the two intercepts. Okay, so whatever P is, that's going to be one of your intercepts on the x-axis, and whatever Q is your other intercept on the x-axis. Now here's the thing to notice. Okay, you have this, it says x minus P. Okay, well if you have an equation where it gives you like x plus P, okay, now in that case, okay, your P is actually a negative number, right? Because negative times a negative makes a positive. So you got to be really aware of whether and what your sign is for your P and your Q. Okay, so if you have a positive P and a positive Q, that actually means that your real P is negative, because negative negative is a positive. Hopefully that didn't get too tricky. We will go over some examples as we go through. Okay, so a few of the steps that we're doing here are exactly like what we've been doing, so it shouldn't be a problem. You just have to know kind of how to substitute some stuff in. Okay, so your steps, if you look at the top of page 13, the first one, we're still going to draw the axis of symmetry just like we have been. Okay, now this time the axis of symmetry, to find it, you do x equals P plus Q all over 2. Okay, so what you're doing is you're taking the average of your two intercepts. Okay, that's an average, right? You add them together and you divide it by however many there are, which is 2. Okay, so you take your two intercepts and you divide it by 2, and that will give you your axis of symmetry, and that'll also give you the x value of your vertex, right? So once you get the answer to that, whatever it is, you're going to plug it back into the equation for x, and then that'll tell you what your y is and give you your vertex. Okay? And then once you have that done, you just take whatever P is, whatever Q is, plot those 2 points on the x-axis, and connect them all, and you're good. Okay? So let's look at an example. Let's do another page here so we can look at an example. Alright, so the first one we have is y equals negative x minus 2 times x minus 4. Okay? So, first of all, we look at this and we see, okay, so we have a negative at the very beginning. Okay, well, if you wanted to, you can put in negative 1. Okay, and so our a is negative, which means that our graph is going to open to the downside. Okay, so now we can move along. So where are we going to put our axis of symmetry? It's x equals p plus q, and so it looks x minus 2, so p is 2, okay, plus x minus 4, so q is 4, all divided by 2, so we got 6 over 2, which equals 3. So our axis of symmetry is at 3. Let me get a graph really quick. Okay, so our axis of symmetry is at positive 3. So I'm going to go over here to 3, and I'm going to draw a line going this way and that way, and we know that it's going to open down, so I want to make sure I get my line going down there. Okay, so now let's figure out the rest of the vertex. So we plug in our 3 to the equation. So y equals negative 3 minus 2 times 3 minus 4. So y equals negative 1 times negative 1. So we got negative 1 times negative 1, so this is going to give us 1. Okay, so our vertex is at 3, 1. So we go over to 3, we go up 1, and there is our vertex at 3, 1. Okay, so there's our vertex. Now we look at our points. Okay, so for P is going to be our first intercept. So on the x-axis, okay, our x is going to be 2, our y is going to be 0 because it's an intercept, and then our other one is at Q, so that's going to be 4, 0. So we plot points right there, 2 and 4, and then all you do is connect them. So there you go. There is your parabola. Okay, pretty simple method right there. If you can factor it down, you can do it pretty quick. I'm not overly excited about this way, just simply because you only have 3 points to graph. Okay, and so that could be a bit of a problem. Usually you want to try to have 5 points when you're doing a parabola. Also, if you do this way and say, for instance, our vertex on this one was like -2 and it was opening down, well, you don't have any intercepts. So you're kind of out of luck with this way if you had that case. So this way won't always work because of instances like that. Okay, so again, though, it's a pretty simple concept. Okay, first you find your axis of symmetry. Okay, so that's that part. Once you find that, okay, you plug it into the equation, and that will give you your vertex. And then all you do is take the number that is P and then the number that is Q, plot those points on the x-axis, and connect them all. That's it. That's all you have to do. Okay. There's a couple of try these on page 14, so give those a shot, and then we'll check them out. Okay, so the first try this you have, y equals the quantity x minus 3 times x plus 1. Your a value, right, there's nothing there, so that means that it's 1. Okay, so your a value is positive, so that means that this graph is going to open up. Okay, and now let's take a look and see what we can figure out. First thing we have to do is find our axis of symmetry, right? Okay, so to find our axis of symmetry, we take P and Q, add them together, and divide by 2. So x is going to equal P, which is 3, and then Q, well, here, look at, we already have, okay, see how it's positive 1, right? Well, remember in our equation, we needed it to be x minus Q. Okay, well, if it's x minus Q, and now we have a plus, that means that our Q is actually negative. Okay, so it's -1 in this case. So it was 3 plus -1, or 3 minus 1, right? All over 2. And so 2 over 2 is equal to 1. So our x value is at 1, and we said we're going to go up. So I'm going to draw my axis of symmetry at the 1. Then you plug 1 into the equation. So y equals 1, oops, sorry about that, got a little ahead of myself. 1 minus 3 times 1 plus 1. So we got negative 2 times 2, and that's going to give us negative 4. So our vertex is at 1, negative 4. Okay, so we go over 1, down 4, and there's our vertex. And now we have negative x equals negative 3, so our p is 3. So we got 3, 0 for our p-intercept. And for our q-intercept, it should be negative 1, 0. Okay, so we got negative 1, 0, and 3, 0. And we have 3 points now, so our graph's going to look something like that. Okay, and again, I would rather have a two more points in there, but you get the idea. Okay, it's a pretty simple process, right? Hopefully your graph looks something like that. All right, let's go on to the next one. Okay, so the last one, y equals negative x plus 4 and x minus 2. Okay, so our a value is negative. Okay, so our graph is going to open down, and then our p, okay, p is, see it says positive 4, so our actual value is going to be negative 4, and for q it's going to be positive 2, okay, because it just stays negative. Alright, and so we go for our axis of symmetry, x equals negative 4 plus 2 over 2, okay, and that's negative 2 over 2, which is negative 1. So our axis of symmetry is at negative 1. Okay, plug in our negative 1. Y equals negative 1 plus 4 times negative 1 minus 2. So that gives us negative 3 times negative 3. Negative 3 and negative 3 gives us positive 9. Wow. So we're going to go up here a little ways, see if I can get these right. So there is our vertex all the way up there at the top. Okay, and then our p is negative 4. So our p-intercept, negative 4, 0. And our q-intercept is 2, 0. Okay, so we're going to go all the way over here, negative 4 and positive 2. And then we can connect them. And there you go. Okay, it's a pretty simple process. You should already know how to do axis of symmetry. You should already be able to find your vertex. And then you just use P and Q to find the other intercepts. It's that simple. Okay, so if you have any questions, feel free to ask. Talk to you later.